All right, so for the first one, I'm going to pull out a 2x, and I have a 2x minus 1 left over. On the bottom, I'm going to pull out a 7, and I have a 2x minus 1. Can I cancel anything? 2x minus 1, so my answer is 2x over 7. Yeah. If there were more factors, then you'd have to combine them once again, but in this case, it doesn't need it. All right? So for this one, I'm going to pull out a 2, and I get x squared minus 9. And what do you notice? You can split the x squared minus 9 as a difference of squares. So we have 2 times x plus 3 and x minus 3. And then on the bottom one, it's a factors into two binomial factors. X minus 3 and x plus 7. So I put those over here. Or wait, it's a minus 7, huh? X minus 7. Can I cancel anything? X minus 3's. So what do I do to get my answer? I have to combine them once again. So I need to times this in, and I get 2x plus 6 over x minus 7. All right, let me show you the most common mistake that people make. Let's say we had 2x plus 6 over x plus 6, and people get really excited, and they say, oh, 6 cancels 6, and x cancels x, and the answer is 2 over 1. Not even close. The only way you can cancel factors is if they are in factor form. So this is 2x plus 6, and that's x plus 6, and they're different. If you can manipulate it in such a way that it would be 2 times x plus 6 over x plus 6, then they cancel. But if that 2 were multiplied in, then you wouldn't be able to see it. So that's a really common mistake. All right. Now this one's kind of tough. I'm going to multiply those together. Negative 24x squared. Now I find the factors of 24 that add to be negative 2. Did you figure out what they are? 4 and negative 6. So I'm going to rewrite the quadratic. 3x squared plus 4x minus 6x minus 8. So I multiply these together, and I get negative 24x squared. I go through the factors of 24, and I should have slowed down. I'm sorry. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I know that the signs are different, and the bigger one is negative. So this list is plus, and this list is minus. Does one of those sets give me a negative 2? 4 and negative 6. So when I rewrite the equation, instead of negative 2x, I put 4x and a negative 6x. Did that help? A little bit? We'll do another one in a second. So group these. What can I pull out of the first group? X. And then I have the 3x left over. If I take this x out, I'm left with a 4. Okay. In the second group, what can I take out? A negative and a 2. So minus 2, and then I'm left with 3x plus 4. Did I do it right? Yes. If this one matches that one, I did it right. Or I made two mistakes that made it right. Okay, so my factors on top are x minus 2 and 3x plus 4. So I'm almost halfway done. I need to factor the bottom. 15x squared and 8. That's going to be 120 x squared. So now I look for the factors of 120 that add to be 26. So 1 and 120, that doesn't work. 2 and 60, that's way too big. 3 and 40, that doesn't work. 4 and 30. 5 and... All right, we'll skip the 6. 6 and 20. Those make a 26. And the signs are both positive. So I rewrite 15x squared plus 6x plus 20x plus 8. Now I group. What can I pull out of the first one? 3 and an x. What's left? 5x plus 2. Is there any hope that I'm going to find a factor that works? Well, is there a chance I have one of those? I might. I have a 3x, so hopefully it's 3x plus 4. Otherwise, we wasted our time. And we found out that it didn't simplify, which happens. Okay, what can I pull out of there? A 4. Yay. That's what I wanted. So, my first factor is 3x plus 4. My second factor is 5x plus 2. This one cancels that one. So my answer is x minus 2 over 5x plus 2. All right. So I want to go over one problem, the one we skipped yesterday. Look at number 9. We're on page 43. That wasn't supposed to, that's the one you, well, maybe I just told the other class. Did you guys figure out number 9? So, can I pull anything out of the top? No. What about the bottom? I can't pull anything out, but can I factor it? Yes, it's a difference of squares. So 2x plus 7 over, good, 2x plus 7 and 2x minus 7. So this factors, if the top disappears, what's left? A 1, and that goes away. So the answer is 1 over 2x minus 7. And maybe I forgot to tell you to skip that one. Sorry. If there were tears, I apologize. All right. So on the next page, we're going to run into cubic equations, x to the third equations. And factoring those is a lot harder, except they're only giving you a very special variety. So hang on for a second, and I'll teach you everything you need to know. If I had x squared minus 9, that's the same as x to the second minus 3 to the second. And that is called a difference of squares. Well, you can also get a difference of cubes. So if I had x to the third minus 27, which is x to the third minus 3 to the third, those are really easy to factor. But I don't even remember the rules. I just look them up. So if you look on page 21, there's a big long table on page 21. So here you see the perfect square trinomials. We talked about those weeks ago. Here you see a difference of squares. We just talked about that. And then cubic polynomials, that was the binomial theorem. Do you remember that when we used Pascal's triangle? So we talked about those. But we haven't talked about sum and difference of cubes. So if I had x to the third minus 3 to the third, all I have to do is follow that pattern. So this factors into x minus 3 times x squared plus 3x plus 3 squared, which is 9. And this one will never factor further. that is always a prime. It's always a prime quadratic every time. But notice, in addition to a difference of cubes, there's also a sum of cubes. And the reason that happens is the same reason that you cannot square root a negative number. If you square root a negative number, you get an I. But if you third root a negative number, that works. Because negative 2 times negative 2 times negative 2 is negative 8. So there is a sum of two cubes. So if I had x to the third plus 1, well, what's the third root of 1? 1. So this is just x to the third plus 1 to the third. So I would do x plus 1, and then just follow that pattern. X squared minus 1x plus 1, and that's how it factors. And they do get a little bit harder. What if I had 64x to the third minus 8? What to the third power is 64? Well, if you don't know, you can always just test it in your calculator. Push math, and then go to number 4. Third root of 64 is 4, so that one works. And then we could do the third root of 8. That one works. So this is 4x to the third minus 2 to the third. And then you just follow the pattern on page 21. So this would be 4x minus 2 times, what's 4x squared? Not 16. So it's 4 times 4 is 16. X times x is x squared. Plus 4x times 2 is 8x. And follow the signs here. Ignore the, figure out which one it is, and then follow, all these signs are correct. So it's plus 8x, and then 2 times 2 would be plus 4. Does that make sense? Yeah, if I were to change this to a plus, then it would change this sign and that sign. That's the only difference. So if that's a minus, then you get a minus here and a plus there. If this is a plus, then you get a plus there and a minus here. Those are the only differences. So if you look, those are the only differences. Is that what you're asking? Okay. All right, you should be able to finish the rest of the worksheet. Good luck to you. There is some difficult factoring ahead, but you guys are smart. Yep, you're going all the way to 21.